Hello, everyone. Welcome to VizConnect, connecting you with the art of data visualization and storytelling. My name is Sagar Kapoor. I'm part of customer success team at Tableau. So VizConnect is your weekly Tableau community call, which helps you to get inspired, motivate, and participate in Tableau community events, learn from our Tableau Zen Master, Tableau public authors, Tableau ambassadors, how you can go ahead and skill up your skills in Tableau. We have a YouTube channel, so all the sessions which are presented on VizConnect are published to our YouTube channel. Go ahead, subscribe to it, some great content waiting for you. We have a LinkedIn group. Go ahead, connect with each other and learn from each other. With that, today is the last day to submit your Ironwise 2021. If you haven't done it, highly recommend go ahead and participate in it. And that will help you to learn some of the new things in Tableau. And one thing, just go to Tableau Public and just search for Ironwise 21 and you will find some great VIZs created by community. Go ahead, re-engineer it and learn from them how they have gone ahead and created their visualization. So just a note, today's the last date before 11:59 p.m. Pacific time. You can go ahead and submit your entry. With that, just an update on the Tableau learning path. This is something which I had created to share all the resources of Tableau which are available on our website to help you to get started with Tableau or to go ahead and understand what are some of the community resources are available for you. I have gone ahead and added two new portions over here in terms of Tableau blueprint assessment, which will help you just to quantify if you want to grow your organization in terms of data culture or grow analytics at scale. So now Tableau blueprint assessment is available for all our customers. Go ahead and take it. And also I have gone ahead and created a Tableau quiz just to help you to understand if you are using Tableau from the last 2 or 3 years, where exactly you lie in terms of your Tableau skills. So I will go ahead and publish this particular Tableau learning path on my Tableau public profile. Go ahead and check it out and let us know your feedback. With that, let me go ahead and introduce our speaker for today, Lisa Rapp. So Lisa is a BI consultant with InfoMotion in Frankfurt, Germany. She has a background in physics, but ventured into the data viz jungle about 2 years ago. She loves helping customers implement modern business dashboard with Tableau and becoming more data-driven. She also teaches training courses for Tableau and data literacy. So without further ado, I will hand it over to Lisa to talk about basic concepts every data viz designer should master. Lisa, over to you.
Thank you, and thank you so much for inviting me to speak here today. Right, so I'll get everything set up and share my screen with you. Here we go. All right, let's get it all set up. Great, I think everything should work fine. Yeah, so this is exciting. It's my first, my first big talk I'm giving to the data community. So I hope it'll be okay. Be gentle. I'll do my best. And right, as Sagar said, today I decided to share with you some basic concepts that I think are really useful in our daily work as data viz creators. And I'll go into what those concepts are and why I think they are useful and important. So Sagar already introduced me, but I'm gonna tell you just a little bit more about myself. So as he said, my background is in physics. So up until maybe 2 years ago or so, the kind of visualizations that I was dealing with on a daily basis, they looked kind of like this. Just 2 examples from that. So I worked in a kind of exotic part of physics called pattern formation. So I often looked at those kind of headache-inducing, interesting stripe patterns like we see here. And then, of course, we just had these more scientific graphs where we tried to explain our results. So yeah, quite different from what I do today in DataViz, but even then, I always thought it was interesting to see how these visual representation can really help to explain those often quite complex topics that we want to talk about in science. And so I guess that part of the DataViz, or that thing about DataViz that I liked, that still stuck around until today. And so today, since I've became more active in the data fam, those are some examples of the visualizations that I create today. So yeah, quite different, but a lot of fun, and I've really learned a lot from the community in those past 2 years, which is really exciting, I think. If you do want to connect with me, my Twitter handle is quite complicated, I will admit that. I always thought about changing it to something that is a bit simpler, but I've never done so, so it's still this kind of mouthful, but yeah, so if you want to connect with me, you can do that via Twitter. Perfect, Saga shared it, that's great. Yeah, and like I said, I now work at a company called InfoMotion, and I'm based in Frankfurt. We have this wonderful office building. It's right by the river. Really, really nice place to work. And in this company, our motto kind of is "We love data," and so I think that probably speaks to all of us that we are here in the data community, and which is also something that just really spoke to me. And in my work in that wonderful company, I do work a lot with our clients, creating dashboards, working with Tableau. But the other really big part that I love doing is that teaching part, right? Where I either teach people how to use Tableau as a tool, but also in this more general way, we developed a training course for data literacy, where we talk about how to be more data literate, how to create visualizations, and how to work with data on a very fundamental level. Right, so when I kind of got the invitation to speak here, and I started to think about what I wanted to talk about, I kind of decided to draw inspiration from that work I do, and especially that teaching aspect that I do. And so I kind of imagined what would be some of the really basic concepts that I would like to teach people who attend my courses. If I could only choose 3, what would be the ones that I would choose? And so that's how I arrived at these 3 basic concepts that I want to talk about today. And what I try to do is kind of show the whole spectrum of data visualization. So the first concept that I'll talk about will be based on the data, will be more a bit technical about the real data aspect of it all. And then we'll go into actually creating the VIZ. And the last concept is more concerned with the overall design of the VIZ that we create in the end. All right, so with that, let's get into it. So like I said, we'll start at the very beginning of each data visualizations. And for that, I think it makes sense for us to take a step back and look at what it actually is that we try to do when we create a visualization. And at its core, what we usually try to do is we try to make sense of some numbers. And so we usually have a data set, some numbers, maybe even quite a lot of numbers. And we are just trying to basically put that into a package that is a bit more digestible or easier or more approachable for people to interpret those numbers. Right, so to look at an example where this basic, so where we start off, so these numbers that are the basis of all of our visualizations. Let's look at an example that most of us will probably know. So let's go to good old Superstore and think about what we're dealing with here. In the Superstore, we have several tables, but I just, for now, let's just look at that orders table. And when we go into that, we'll see that it's a fairly large data set, right? We have 21 columns of data. There's almost 10,000 rows in that table, and right. So that's what we are being dealt basically. And of course, we can now take that and then create some nice visualizations based on that. For example, this little bar chart over here where we see the sales by region. Now let's think for a second about what happened when we went from those 10,000 rows of data to this visualization that we have over here. So obviously there's some design aspects, and that is something we'll get into later. But something else happened here, and that is we went from those many numbers that we have in the data set to just a few numbers, right? So basically only those 4 numbers that we saw in the bar chart. And the thing that happened over here, the technical term for that is the aggregation, right? So we put all of those individual numbers and we summarized them to get our sales by region. And this is where this concept of granularity comes into play. Now, what do I define as granularity in this context? So for me, granularity means the level of detail of your data, or in maybe putting it a little bit simpler, granularity tells us what one row of our data represents. So again, let's head into the Superstore to see what that means. So like I said, granularity, we want to find out what one row in our data will represent. So to find that out, it's actually not something that is always immediately clear. We really have to just go to our data set and try to figure it out. Basically, what we're trying to do is we want to look what each row makes it unique. So in the Superstore data, we see that we're dealing with some orders, but obviously it's not, one row does not represent an individual order, because we can see, for example, that this order ID is repeated in the next line. So that is not the distinguishing factor here. And so we have to go through it basically column by column and try to figure it out. And then you might end up seeing that in the product name, that's where we see another difference between the 2 lines. And so, yeah, as it turns out, one row in the Superstore orders table represents one item in a specific order. Right, so example, so this is an order that Ed Brexton ordered something from our store. And he ordered 2 products. And so each row in the data set is one of the items that this customer ordered. Okay, so once we figured that out, it's great. Now, why does this matter? And I would probably argue that if you build something like this visualization on the left, it probably doesn't matter that much, and you probably didn't think about it too hard. But I can make just a tiny change, and then I'll hopefully show you why it does matter in many cases. And I can go from this to this, and it's just a tiny change you might not even have noticed, but it's this over here. Right? So in Tableau, it's super easy to do, right? I just went into our sum of sales, and I changed the aggregation type to average. And so we get our average sales by region. And so now we can read, okay, in the central region, the average sales is $173. But my point is, what does that even mean? So what does that $173, what does that represent? And here my argument is we can only really explain or understand that if we are familiar with the granularity of our data set, right? So if we really go down to the data level, which we now found out on the data level, we are dealing with individual items in our order. Then we know what these individual numbers actually stand for. So in our example, it's the sales value of a single item. And once we understand that, we can now see that, when we are going to our visualization level, which in our example was the region, then in order to get there, we have to take all of these numbers and condense them into this one number, which we saw, the $173. And now because we know where that $173 came from, that's why we can now interpret that number. So it's the average sales, but in this context, we can now understand that means the average sales value of an item. So if someone in the central regions buys a single item, then on average, it will cost $173. So this is why this is basically why we need the granularity. If we think about it, this aggregate number that we got, it only really makes sense when we are aware or familiar with the granularity of our data. So, and once we are familiar with that concept of those different layers that we have, so that there is a data level, which in our case were the individual items, and then there was this visualization level, in our case, the region. And once we are familiar with this concept of there being those different layers of detail that we have, it's also quite easy to imagine that we could also go in between, right? And for example, say I want to look maybe at the average sales a customer did, and then look at it from a regional perspective. And that's where, so every time we go in between those two, those data granularity and our visualization level, that's where, for example, things like our LOD calculations will become important. All right, so to sum that first part up, in my definition, granularity means the level of detail of your data. And it's an important concept to understand because it helps understand those aggregation. It puts them into context. And once you understand the concept of detail, of levels of detail, then you can also understand those more complex calculations, such as the level of detail calculations. Okay, so we've started with our data. We've familiarized ourselves with the data, and we now understand how we summarize them in order to create the visualizations. So now we can go to actually creating that VIZ. And again, let's take a step back. Let's think about what we actually are trying to do when we create a VIZ. So like I said, we have these numbers. Most people can't really gain a lot of insight from the raw numbers. So what we are trying to do is we try to translate those numbers into visuals. And now that translating of the numbers into visuals, that's where the concept of visual encoding is important. Because visual encoding is the way in which we do that, translating the numbers into something we can see with our eyes. And there are different ways of doing that, different ways of visual encoding elements, I want to call them. So for example, you can go and take and create an axis, and then depending on where you put an object on that axis, that way you can encode a certain value. Or you can take the length of an object, and then basically the idea is the longer the object, the larger the value you want to encode. And so on with a few different ones. You can take the area, so that would basically be the size of your object. So the larger the more area it occupies on your screen, the larger the value will be, and so on. So those are just a few of them. There are even more than that, but I think those are the most important ones that we use often in databases. Okay, let's look at a simple example. I think there is not a lot to misunderstand in that case. So if we create a simple bar chart, and of course we use the visual encoding of the length. So the information in that case is stored in the length of the bar. That's why when we go there, the bar that represents 25% will be about twice as large as the bar that represents the 13%, and so on. Yeah, so I think that's not very much up to debate in this case. I'll maybe give you an example where it's not quite as obvious, and that is a line chart. A line chart will use the orientation as the main visual encoding. And orientation in this case means basically the slope of the line. So does it go up? Does it go down? Is it steep or is it more shallow? And that's maybe a little bit surprising, because if you imagine how you would draw that line, you would probably go and kind of create an axis and then, you know, pick the points, different points in that axis, and then connect them to form the line. And so, of course, there is an aspect of position involved in that. But when you really think about what the main information in the line chart is that you are interested in, then it's more apparent, right? It is actually the orientation, because when you look at line charts, you're usually interested in seeing where does it go up, where does it go down, right? So if you look at these very minimalistic lines we see over here in these spark lines, you'll immediately go to the points where, for example, the line suddenly goes down or goes up again, and so on. So in this case, the orientation is the important, the visual encoding we use. Okay, why does this help us? Why do we, I mean, it's very technical. Why does it help us to think about it that much? So the first reason why I think it's useful is because it helps us avoid some common pitfalls that we might accidentally fall into. For example, this is again a bar chart. We've talked about bar charts before. And so we see those are just for years, and for each year we have the yearly sales. Now, if you look at that closely, you might see why there is, or why we might encounter a problem in this case. So if you really look at it closely, you see that in this case, the axis doesn't start at the 0 level. It starts at, I don't know, somewhere above the $400,000 mark. And now what is the consequence of that? Now the problem is, in the bar chart, we expect the information to be encoded in the length of the bar. And so if we see that 2019 bar, we would expect that sales value to be about twice as much as the 2018 value, because that bar is about twice as long as the 2018 bar. But when we look at the numbers, we see that that's obviously not the case, right? And that is because we truncated that axis. So my rule of thumb for that is always be aware of where your information is stored, and then just make it as easy as possible to access that specific information. So yeah, in this case, if the information is stored in the length, then you really want to make sure that the length is easily visible. And so if, for example, in this case, you want to show the whole length of it and not cut anything off of it. Okay, I'll give you a second example for that. And over here we have basically a nice little map where we have the birth rates for different counties in the US. So of course, what we want to do is, in this case, use the color as the visual encoding for our data. Right, and so you can go into this VIZ and you can look at the different counties, and then you might want to compare in which county is the birth rate higher and where is it lower. Now, the problem with that is that because of the color scale that we use, this comparison is actually not that easy. So if you have two counties that you maybe want to compare, you really have to go into the legend and kind of compare. Okay, this one's yellow, so this is somewhere in the middle, and then this one is, I don't know, this purplish, so that must be somewhere down there. And so it's not the easiest color scale to understand. So again, because we put the main information in the color, let's just make sure that the color is as easily accessible as possible. So for example, changing the color scale to something that is quite clearly going from one dark color to another lighter color in a continuous scale, it makes it a lot easier to compare those different colors with each other without really having to dig into the legend over there. Okay, and the last example for that is where we can come back to our line charts. So we talked about how they use the orientation. And if we know that, we can understand that the way we present our data might actually influence the way we perceive the data we see. So in this example, we have the exact same data, right? It's just some measure over time. It's the same time span. It's the same values that we see here. But obviously the only difference really is kind of the aspect ratio of our chart. So on the left, it's kind of more compressed. And on the right, we kind of stretched it out a bit more. And the result of this stretching and compressing is that the slope of the line has changed. Right? So on the left, we now get this pretty steep increase, and on the right, it's more shallow. And so because we are looking for that orientation, for that slope as the main visual encoding that is used, this can really just have a really different impact. So on the left, we might be tempted to think that that increase we see from 2001 to 2007 is maybe quite dramatic, right? And while on the right, the same data, it might give us the impression that it's more of a steady climb. So yeah, really being aware of where that information is can maybe help us understand how others will perceive that information. And then we'll just have to, in this case, just find some middle ground between stretching it really, really wide and really slimming it down a lot. Okay, and so once we understood how those more simple graph types work, we can now use those visual encodings to layer information. So basically, each time we want to add a new information, we'll have to add a new visual cue. And so I think this is quite a nice example of such a composite VIZ. This one is by Eve Thomas, and it shows this kind of dumbbell charts we see here. And so this uses two visual encodings for two types of information that we see here. So on the one hand, we do have this axis down there, and we have those dots that are positioned along this axis. So one visual encoding we have here is the position along the axis, and that shows us those different percentages. But then we also have that line or that bar that is between those 2 points. And so that uses the length, the effect of length. and it shows us the information of the divide between those 2 points. So the longer the bar is, the more divided, or the larger the divide between those 2 percentages will be. And of course, this is just one example of many. So that's just a way we can build any kind of very complex visualizations if we want to, just by adding those layers of information, by adding layers of visual encoding. So we've talked about how creating the VIZ, our job when we do that, is to translate those numbers into visuals. But one thing that is quite important to remember is that this is not a one-way street, right? Because there is the other direction. If someone goes in and is looking at our visualization, then what they'll have to do is they'll have to take those visuals and translate it back into the numbers. So they'll have to be able to see those things, for example, that, I don't know, the sales grew or doubled from one year to the other. They can only see that if they went into the visual and translated it back into the numbers. And so an important aspect of the visual encoding that we should be aware of is that this process of having the visual and then translating it back into an accurate number, it's not the same for every visual encoding we use. So for some visual encodings, such as the position, it's easier to get at an accurate number when we do that translation. But then for others, it will be quite hard to do and will just end up being less accurate. So I can show you with an example again. So if we use the position, so I got this axis, and then if I tell you the green square represents the number 2, and then I ask you, what is the black square? Which number does it represent? Then I guess it'll be pretty easy for you to kind of just, count the distance on the axis and then be like, okay, it's probably something like 5. However, if we do the same little game with the area, so now the information is stored in the area, and I again tell you this green square represents the number 2, which value does the black square represent? Then you'll probably have a lot harder time to put an accurate number on there. I think it's actually 6 in this case, but yeah, it's just the reason is we're really not good at estimating the area size and then comparing those two. It's just not something we are very good at doing. And so again, knowing this, we know what the visual encoding will have, what impact it will have on our reader, the ones who will look at our visualization. So again, if we do something like this, right, where we now have the monthly sales and it is represented in this kind of bubble chart. So the larger the bubble, the larger the sales will be. So this uses area as our visual encoding. And this is sort of a fun VIZ, I like bubbles. I think that it looks nice and it's, it's something different. I kind of like it. However, if you have someone like that person on the right who's really interested in those accurate number and who really wants to maybe know how much did sales increase from August to September, then that person might not be very happy about this kind of VIZ because he will just have a very hard time getting to those numbers. So for that person, the simple bar chart will maybe be a lot more satisfying, right? Because they'll be able to see, okay, August to September, I want to say sales almost doubled. So what it means is, it doesn't mean you should never use the area. I've done so myself because sometimes I'm just like, okay, I don't really care about the exact numbers. I just want to look at some colorful bubbles and just have a little bit of fun. But it's really helpful if you are aware of the shortcomings that a VIZ like that will have, because you are using a visual encoding that is just not going to be, or that people will not be able to translate into an accurate number. Okay, so visual encoding is the concept by which we translate those numbers into visuals. And as I hope I was able to show, is that it's an important concept because it just helps us very generally understand how VIZs work. When we are aware of them, we are able to avoid some common pitfalls. And it also helps us understand how our readers will interact to our VIZ, or how that VIZ will, what impact that VIZ will have on the people who will look at it. Okay, and then with that, let's go to our third basic concept that I'll talk about today, and that is the concept of visual hierarchy. So like I said, we started out at this really basic data level, and we've now talked about how we are able to translate those numbers into visuals. And so at this point, we probably want to, finish it all up, put it all together, maybe create a nice dashboard, or just, an overall nice visualization. And so this is where the visual hierarchy becomes important. The visual hierarchy is a concept from graphic design. It's often used for website design and so on. But what it means is it's basically the order in which we perceive visual elements. Now, ideally, what we want to do is we want to create a visual hierarchy that mimics the importance of the information that we are showing. So you will want that our visual hierarchy to be designed in a way that the most important things will be seen first, and then, going down to more the detailed information that maybe is just a bonus and not as important to see. So what do we have? How can we create that visual hierarchies? What are some of the methods that we can use to create that? One that is, I think, pretty obvious because it's just something we're quite familiar with, is using size. So especially in context of text objects, of course, the size is something we are quite familiar with. Bigger text, we're thinking about headlines, so that will be more important than some of the smaller texts. But that also applies for objects in general. So large objects that just take a lot of room will be deemed more important than smaller objects. A second really effective method to create visual hierarchy is color. So this could either be contrast, so objects that have a high contrast compared to the background will stand out more than those that kind of blend into the background. Brightness is a way in which the certain colors really pop, like this really neon yellow, it just sticks out. And then also in database, combining colors with grayscale or black and white will also create the way in which the colored item in the sea of gray will also stand out and be deemed more important. Let's look at an example. So this over here, which is just this kind of a normal scatter plot. But what we have here is we really haven't built any visual hierarchy at all, because we only use black and white in that scatter plot. And so there's no variance in the contrast. And as a result, your eyes, they don't really know where to start or where to go and where to settle. And that is just because really we don't have that hierarchy in there. And let's compare that to over here, where we're just working with different contrasts. And so now we have that clear visual hierarchy. So we definitely will see that line first, and we'll then see those individual dots, and then maybe go to the grid lines that are really in the background and not as important. And then the fourth important way to create visual hierarchy is by the alignment of the objects on the page. So that is, again, something that is very important in web design, but I think it also applies to our visualizations. So there are a few very common patterns people use when they scan a page. And one would be to start on the left and then kind of skim down. And whenever something interesting is happening, they'll jump to the right. And that is the F-shaped pattern. And the other one is a Z-shaped pattern where they start on the top left and then go to the right and then down to the left again and end at the bottom right. But we have to say those are really Western culture things, because that's just also aligns with the way our writing is from left to right and so on. So it doesn't apply to all cultures. It's actually a cultural thing, but those are two that are very common in Western cultures. And again, we can use that knowledge of what the typical order is in which people look at pages or look at objects on a page in order to create our hierarchy. Now, if we put that all together and we believe that we've created a good hierarchy that represents the importance of our different information, how do we know if it actually works? I always tell people do a squint test, and I was quite happy to learn that it's actually a thing. It is a concept in graphic design that is actually used. So it wasn't only a stupid idea that I had. So yeah, it's just basically go back a step, maybe squint your eyes a little bit, and then look at what still sticks out to you. And ideally, if your hierarchy works, you'll see the most important parts you'll still be able to see, and the less important things will blend into the background. Let's look at an example how this might look in practice. I brought this really nice dashboard created by Alan Blackburn, which I think is, it's really nicely done. And so this dashboard, it includes a lot of information. Right? There's a lot on there. It's densely packed information. But I think she was able to build a visual hierarchy that helps us to not be lost in this and that guides us through the whole dashboard. So there are a few aspects here. We have, for example, that F-shaped pattern, right? That goes down here, and then interesting things go down to the right. And we're working with colors. We have those darker elements over here that are in more contrast to the rest, and so on. And then there are also pops of color, and so on and so forth. Now let's put that to the squint test. I'm going to squint it for you just by blurring it. So this is still where we see quite a lot of detail, but we can go even further, or we can go completely crazy and just blur it all. But you'll see that even in this blurred stage where we really don't see any of the details, you can still recognize that hierarchy. You can still see where the title is. You can see that there's some interesting stuff going on the left, and you might see those pops of color and those darker elements that are probably more important than the others, and so on. So yeah, I think it shows that the squint test is a nice way of looking at it with a fresh set of eyes also, because you get you will be, if you're working with your VIZ, you will be very familiar with it, and you might not even see it. So the squint test is a good way of looking at it in the end from another perspective. All right, so that was the visual hierarchy, which basically just means that we are ranking our visual elements by importance. And I think it's important because it guides the user to the most important information. And with that, we are able to tell this cohesive story that we are trying to tell with our visualization. And that is it. those are the three concepts that I wanted to share with you today. So yeah, we went from the data level, where I think granularity is an important concept to understand. And then we created the VIZs by using the concept of visual encoding. And then finally, if you want to elevate your design, then the visual hierarchy is an important concept to master and to use. And I think with that, if you have those three concepts, you're really equipped to build, I think, great visualizations. So yeah, I hope you learned something today, and I was able to give you some new information. And thanks so much for listening. I think we still are able to answer some questions.
Thank you, Lisa. Thank you for sharing these critical concepts for data visualization. And I think they were helpful for everyone. So if you have any questions for Lisa, just go ahead and put it into the chat or Q&A. Happy to go ahead and answer. Ask her over here. So maybe in the meantime, I think, Lisa, I can go ahead and ask you a quick question about your Tableau journey, right? How it got started and what was some of the important things when you started learning Tableau you will advise the beginners who wants to go ahead and start their Tableau journey?
So yeah, I think I kind of still feel like I'm on that journey, especially when I think of those concepts. I think I'm pretty. I've done the visual encoding is something that I've really I think I'm quite familiar with. But when it comes, for example, to that graphics design aspect of it, that's still something I'm often struggling with. And so in this case, I think it just helps really looking at a lot of examples and just figuring out or really trying to understand why some designs speak to you and others maybe don't. And you know, just really questioning what you are seeing, I think, is an important part of it. Just not only looking at it and trying to understand the technicalities, but really just questioning what is happening in the background and what were the choices that went into that. And that, I think, is just something that where it helps to just look at a lot of examples, which they are all out there, right, in the data farm and on Tableau Public, and then really thinking about what went into creating those VIZs.
Thank you, Lisa. And what has been the role of Tableau community, right? I think you have been a Tableau Public featured author. How did Tableau Public help you? If you want to go ahead and talk about that.
Yeah, it's been really influential because of course I use Tableau at work all the time. But of course, that's also that's business context usually, and so I think it really helps the Tableau community. For me, was a way to kind of stretch my muscles beyond what I do at work. So just doing different stuff, and that helped me really learn a lot of things that I otherwise might not have even tried. So it's really just seeing those. Seeing the possibilities out there and then just learning so much from the community because people are so happy to share their knowledge and share techniques and things. Then you're really able to just learn so much that you wouldn't have been able to do by yourself.
Thank you. So Lisa, Ralph is asking, when you have finished a visual, how do you make an assessment to make sure there is not too much information that overwhelms the eye?
Mm-hmm. So again, other than the squint test, I mean, it always, ideally, I think you would always have other people look at it. And because at some point, you know, you yourself, you will not be able to really judge it neutrally because you've been looking at it for a long time and you've been really into the weeds of the data maybe. And so it really is important to have someone else look at it and so find a way to find out how others interact with it. And a way by doing, yeah, so it would be just asking others. I know that some people actually use like eye tracking software to do it, which is also a cool way, but of course that's a technology that you'll have to have accessible. But I would do just if you don't have that, just do the manual part of it. Have someone interact with your Viz, or maybe ask them some questions about it. You know, have them find out some insights and try to assess whether they are able to gain those insights you want from the visualization.
Thank you, Lisa. Any particular website you go for Tableau learning? Like anything you want to share with the community, or maybe a particular book you are inspired?
Oh, I got that one book that I totally love. Wait. That I got recently. I don't even know where my camera is. This one over here, which is the Data Visualization Handbook, which is really, goes a lot into those basics of the visual encoding. I think that's, yeah, it's just a really nice book. It's well made. And other than that, of course, there are a lot of blogs I don't feel like mentioning because otherwise I'll leave somebody out. But no, I mean, it really is just if you know, I've often used obviously the Flourish Twins blog because they have so many great technical descriptions. Also, if you want to, you know, learn some of the technical aspects, they're great. Or yeah, really, I just go in, type my problem into Google, and you'll come up with some great help, which is really cool.
Thank you, Lisa. And I think this is one thing which I have been trying to talk to my customers. Like when they start using Tableau, one thing which they try to do, they start to replicate. Maybe they were using Excel before, and they will start to replicate the same Excel graph, right? And one thing which they always has an excuse is that our executor will not like this particular chain. So that's the reason in Tableau also we have to just go ahead and define something. We take a printout or send a PDF. So what has been your experience, right? How you have gone ahead and tackled a situation like this?
Yeah. That's a very realistic scenario that we find. I mean, you really did. The thing is, if you can't go from from tables, let's say from raw tables to super interactive dashboards in a day. You know, so it takes some getting used to for people who will have to use it. So I think one method that we often use is getting people familiarized with it more slowly. So you might start with, you'll still provide maybe your table. So for the people who are used to that, you might give them that. But then you'll add maybe an overview dashboard in the beginning where you kind of show some types of visualizations that they maybe haven't seen before, and then hopefully they'll find that it's actually quite useful, and so you can build on that and then, you know, take it step by step.
Thank you, Lisa. And I don't want to put you on the spot, but do you want to talk about your Ironwise? Anything you want to share with the community?
Yeah, my Ironwise, I did finish it, which was I wasn't so sure about that because I didn't have a lot of time. Yeah, so my Ironwise is about my favorite musical, which is called Come From Away, and it's a really incredible, based on a true story, and so I tried to tell that story again. And it was really cool publishing it because kind of I tagged the producers of the musical, and they responded to it, which was really kind, and they liked it. And so, yeah, in my book, I've won for myself because it's been fun.
And what has been your inspiration and motivation to participate in Ironwise, right? Like, I think what was your challenge? No, I have to go ahead and participate in competitions like this.
I think Ironwise is obviously very special. It's not. I don't often create those really intricate VIZs. You know, I'm usually when I create a VIZ, it's usually a single VIZ, and then I'll try to really get that done. But that storytelling aspect is something that is challenging for me because yeah, I just don't do it as often as creating maybe a single nice visualization. And that was a huge, it was hard, but it's really something that I think you can learn from, because that also applies to any dashboard you build. You really want to tell a story with it. And so, yeah, that especially is something I've only ever really had the motivation to do for something like Ironwise, where you really dig into it and think about it for a long, long time and really take your time doing it, you know, not just maybe take a pause for a few days and then get back to it and work on it again.
Thank you, Lisa. I think with that, thank you so much. It has been an honor to have you on VizConnect. Thank you for sharing all the best practices and how we can go ahead and upscale our skills in Tableau.
Thanks for having me. Bye-bye.
Perfect. So I think with that, thank you everyone for joining. Take care, be safe, and we'll see you next week. Thank you.